Good morning, good afternoon, and good evening. Welcome back to Chapter 2. We're talking about chemistry. Whee! We just got done talking about compounds and the states of matter. Remember, the states of matter are solid, liquid, and gas. To turn the solid into the liquid, you add energy. To turn the liquid into the gas, you add more energy. To turn the gas into the liquid, you remove energy, remove heat. To turn the liquid into the solid, you remove more heat. Remember that compounds are made of elements. There are, as I've already said, 92 naturally occurring elements. 96% of 96% of all living things are made of these four compounds. Right? Sorry, elements. Oxygen, carbon, hydrogen, and nitrogen. And we already said that you are 75% water. And what is the formula for water? H2O. So that's 75% of it, hydrogen and oxygen. The other 20-ish% is going to be made up of really, truly, mostly carbon, and about 2 or 3% are going to be nitrogen. Trace elements are essential, which means we have to have them, but as the name trace implies, we don't need a lot of them. We need a little bit, but not a lot. You know already a lot of things, a lot of trace elements that you need. You know that you need iron. You need iron for your blood. You can't see it down here, but this is F for fluorine. You need fluorine for strong teeth. Here is the breakdown of the primary elements that you need. We just said a little while ago, 96% oxygen, carbon, hydrogen, nitrogen. This is what you need. From there, these trace elements that we just mentioned, we said one of the trace elements that we mentioned was iron. We need iron. Look, not even in this right here. What is the top trace element? Calcium, though you did know you needed calcium. Strong bones and teeth. We'll talk about that later. Phosphorus, potassium. The other things, they're down here, the trace ones, like iron right there. That's one of the trace elements. Zinc, tin. Did you know you needed tin? You need tin. You need vanadium. You ever even heard of vanadium? It has nothing to do with Canadian. Vanadium. All right? Molybdenum. Say that 5 times fast. Molybdenum. These are trace elements. These are elements that we all need a little bit of. This is the periodic table. I hope you've seen it before. We will talk quite a lot about the periodic table. I understand that it has sort of a strange construction. It's built odd. But it's not built odd just to be original. It's built odd because the elements are grouped based on behaviors. If an element is the same color and in the same column, it tends to react similarly. So these right here, these will all react similarly. These will all react similarly. These will all react similarly. Those will too. So let's talk about the periodic table. Let's talk about a single entry. Let's pick carbon because carbon is easy. Carbon is element number 6. Its atomic symbol is C, and its mass is 12.011. Okay? So when we look at the entry for carbon, this is what we see. Its atomic number, its atomic symbol, and its atomic mass. This atomic number means a couple of things. The first thing that it means is this atomic number is equal to the number of protons. We'll talk about protons in just a second, but protons are found in the nucleus. So how many protons is carbon going to have? If it's element number 6, it means it has 6 protons. That 6 is also equal to the number of electrons. 6 protons, 6 electrons. Protons are found in the nucleus, electrons orbit the nucleus. The last thing that you need to make an atom are these things called neutrons. In our entry here, 6C12, it doesn't say anything about how many neutrons there are, but we can figure it out. That's because the number of neutrons, you can determine it by subtracting the atomic number from the atomic mass. So carbon's atomic mass is 12. For this moment, or for at this time, just round it to the nearest whole number. Okay. What is carbon's atomic number? 6. So 12 minus 6 is 6. This is the number of neutrons. The mass is equal to protons plus neutrons. Up here, I've got the mass, I've got the number of protons. With a tiny bit of algebra, I can figure out the number of neutrons. All right? So within this little box that only has 1, 2, 3 pieces of information, I'm actually able to get 5 pieces of information out of it. The number of protons, the number of electrons, the symbol, the mass, and the number of neutrons. I can actually get quite a lot of information out of one of these boxes. The reason why we round to the nearest whole number is that, and we'll talk about it in just a second, it's that not all atoms of an element are identical. They'll all have the same number of protons, they'll all have the same number of electrons, but they will have different numbers of those neutrons. We'll talk about it in just a second. We just said a second ago, an atom is the smallest unit of matter that still retains the properties of that element. Can you take an atom apart? And the answer is yes. Yes, you can take an atom apart, but does it still retain the properties of that element? And the answer is no. Just like, what is the property of your car that you like most about it? The fact that it gets you somewhere faster than your feet. Can you take your car apart? Yes. Does it still retain that property that you like about it? No. An atom is the smallest unit of an element that still retains the properties of that element. Atoms are made of 3 things: protons, neutrons, and electrons. Protons have the symbol P+, P for proton, plus for its charge, positive 1. Protons are found in the nucleus of the atom. And protons have a mass of about 1 AMU. AMU stands for atomic mass unit. It just means a proton weighs 1 proton. It really is exactly what it means. Neutrons. Neutrons are also found in the nucleus. Neutron symbol is N0. N for neutron, 0 for its charge. No charge. Neutrons also have a mass of about 1 AMU. Electrons. Electrons orbit the nucleus. An image that you should have, you can use for an atom. Kind of imagine the solar system. The sun's at the center. That would be the nucleus. And then the planets orbit the sun. The electrons orbit the nucleus, similar to how the planets orbit the sun. Okay. Protons and neutrons are in the nucleus. They have a mass of about 1 AMU. Electrons orbit their nucleus. Their atomic symbol is E negative. E for electron, negative for their charge, negative 1. And they effectively have no mass. Understand, they do have mass, because that was like the first thing we said today, is that if it takes up space, then it has mass. And if it has mass, it takes up space. So electrons do have mass. It's just that its mass, the mass of 1 electron is so tiny that you don't even need to worry about trying to taking it into account when we are calculating the atomic mass. The mass of 1 electron is so tiny that we don't take it into account. Well, isn't that what the .011 thing is about? No, that is not what it is about. The mass of an electron is so small as to be ignored. It's sort of like when you go to the doctor's office. When you go to the doctor's office and you step on the scale, some people would put their bag down and they might take their phone out of their pocket, and they might take their keys out of their pocket. Some people even take their shoes off. Why do they take all this stuff off? Why do they take their shoes off before they get on the scale? Well, they want an accurate reading when they get on the scale. They don't want all this extra stuff to making it seem like they're heavier. Well, should you go in and pull the lint out of your pockets before you step on the scale? No, that's absurd. Well, why? Does the lint not have mass? Don't you want to get an accurate reading for how much you weigh and not all this extra stuff? Well, yeah, but the lint is so small that it won't affect how much I weigh at all. Right. Electrons, their mass is so tiny that it does not affect the mass of the atom at all.